Hello everyone and welcome to Module 20 in our series about teaching science in the FET phase. Let's first start by looking at our video on motion. Measurements of length and distance depend on the instruments we use and how we use them. It follows that the instruments used must be appropriate for the task and that people need to be properly trained to measure and to recognize where errors may creep into the process. In a motor engineering shop, for instance, accuracy is very important.
Well, this specific one is ADE 366, and the housing size that we've got aboard to is 93 millimeter. You are allowed to go to 9302, which is the maximum spec on it, but we'd like to keep to a minimum spec of 93. It's 0.200, it's 200ths of a millimeter. That's between your minimum and your maximum.
Some instruments measure to a fraction of a millimeter, while with others you only need to be accurate to say a tenth of a kilometer. In space, the distances between planets and stars are so great that measurements are often only spoken about to within an accuracy of 1,000,000 kilometers. When looking at molecules and atoms, on the other hand, distances need to be measured to the level of 1/1,000,000th of a millimeter or less. Accuracy thus depends on the need and the ability to measure. To measure speed, the big issue is to ensure that distance and time are measured together. This can be done in three ways. We can time the movement and measure the distance traveled afterwards. We can set up a standard distance, such as an athletics track, and measure the time needed to cover that distance. And we can mark off distances at fixed time intervals, as is done with ticker timers or stroboscopic multi-flash pictures. The measurement of acceleration requires more thought because it involves a change of speed or velocity, and this is a change of change. The intended outcomes for learners are understanding the reasons for errors in measurement of length or distance and the resultant limitations of the measurements, getting learners to grapple with the simultaneous measurement of distance and time, and involving learners in the planning and carrying out of the practical activities, including deciding on what measurements to take, what data to record, recording the necessary data, and using the data for interpreting what happens.
So I'll give you the cloths, and then I'll give you something you will use for measuring it.
The educator in this classroom has been asked to give the learners a chance to practice measurement as they think it should be done, to watch them and to see how they approach the measurement, from being highly accurate to making substantial mistakes. Each group is given a piece of cloth to measure.
And this one, what's this color? Pink. Okay, what I want us to do, I'm going to give you some instrument that we are going to use to measure the different lengths on those cloths. Give you this one. And this one.
It's 51 centimeters. It means 1 meter there.
I want you to record down the color of the cloth as well as the measurement.
The pieces of cloth are then swapped between the groups so that each group gets to measure all the different items.
Ever since I started teaching physical science, I've been using groups. The advantage is when you're working in groups, they get to interact with one another and they discuss, they share ideas. Other than when we're not working in groups, when you are just asking them questions, and they are more free if they are in groups other than talking straight to me. Use this, and you use this. We've done with our measurements. What we are going to do now, we are going to take your readings from each group. And then we are going to compare the readings, and then we'll discuss those readings. Okay, firstly, I'll start with group 1. So it must be the width or the length. You must specify whether it's the width or the length.
The groups all write their measurements on the board.
Who is going to do it for us in group 2? So what I want us to do now, I want us to look the measurements from different groups. We look at the different recordings.
It becomes apparent that there are some noticeable differences in their results.
By looking at things, I can see all this. We've got one cloth, but we've got different measurements. Why do we have different measurements?
The learners are asked to discuss potential reasons for these differences in measurement.
Okay, let's look at the factors. Group 1, what were your reasons?
In our group, we found that while we were measuring the cloth, we discovered that the width of the same cloth were not equal, which means it was not accurately.
The width wasn't equal. Group 2.
When measuring, others were stretching the cloth.
When measuring?
Yes, others were stretching the cloth, so it can be.
Yes, stretching the cloth. Going to group number 3.
It's because of the error of parallax.
Okay, to the last group.
It's inequality of sides.
Inequality of sides.
Sliding, please.
Looking at these reasons, we should know that whenever we are measuring, we've got this factor, accuracy, as well as error of parallax.
Every measurement that you make, unless it's a counting measurement, is limited by the instruments that you use. Every instrument has, whatever it is, has a limitation in terms of its precision. Now, a lot of science has advanced by increasing that precision. So once you could measure to, say, 100th of a millimeter, it means you can do some very precise things on the macro level.
The measurement of speed requires a simultaneous measurement of distance and time. This can be achieved by marking the position of the moving object or person at carefully timed intervals. In this case, by the activity of dropping small plastic balls at 1-second intervals.
I want us to walk fast, dropping each ball each and every second I count. 1, 2, 3.
The first learner is asked to drop a plastic ball every second while walking at a constant speed. Another learner is asked to repeat the experiment, this time walking very slowly, still at a constant speed. The teacher continues to count out the seconds.
5, 6, 7.
This activity can also be done where the learner speeds up or slows down, thereby demonstrating acceleration. The value of this activity for the learners lies in the direct experience of the process.
Let's look at the spacings between the plastic balls. Look at the first row, that's the first practical, and then the second one. In both cases, we were counting the same time. But look at the spaces. Are the spaces for this one the same as the spaces for the other one? No. The spacing is not the same. What does it tell us?
Yeah, it says that this, on the other side, the speed was slowly, and the other side was high.
Because the spaces are smaller, the speed was slow. And the spaces where the spaces are bigger,
then the speed was high.
The speed was higher than the other one. So to us, this practical demonstrate to us, even though that we're measuring the same time, but the speeds were different. So the balls are showing us the speed was different using different spacings.
The different kinds of motion are analyzed by identifying the spaces as representing both distance and time. This means that the measurements can be used to explain the concepts of distance, speed, and acceleration in terms of the distribution of the plastic balls. The following activity reinforces the work done with the plastic balls.
So right now we're going to use something accurate which we call the ticker timer and the ticker tape to demonstrate the speed of an object. So from group 1, I will need 2 volunteers which are going
The use of the ticker timer is sometimes questioned as there can be problems attached to the interpretation of what is seen and measured.
While pulling this tape,
However, it is usable in the classroom and provides quick results if used suitably and if the learners are properly introduced to the device.
When you turn it on, as soon as you turn it on, I want you, Michael, to pull the ticker tape at a constant speed. So you mustn't change speed. You just pull the ticker tape. So hold on to the ticker tape. Switch it on. So this is for the first group. Switch it on.
Different groups are allowed to try out the ticker timer. They discover that with constant motion, the dots on the tape appear at regular intervals.
Okay, I'm going to demonstrate to you how we put this thing in here. So one of you will hold the trolley and put the wooden blocks underneath, and the other one will switch the timer on. So let's do it.
The next activity involves accelerated motion. A trolley is allowed to run down a track with increasing speed.
Okay, switch it on. Okay, Shenge, let's take out the tape. You take it from this side, pull it from this side. Okay, I want us to look at the tape, look at the dots.
The learners discover that the spacing between the dots increases as the trolley speeds up.
One are more far apart from each other, but this side are more side to each other.
Okay, group one, looking at the tape, what can you tell us about the dots?
The spaces between the dots are equal.
What does it tell us about the spaces between the dots if they are equal? We had constant speed. Okay, group three, looking at the tape, what can you tell us about the dots from the beginning, Togozo?
In the beginning, the spaces are small. When you go on, the spaces become larger.
The spaces are becoming larger and larger. It means we don't have uniform speed, so we've got increasing speed. So now what I want to show you, I want to show you a more accurate, practical.
The learners are now ready to understand the concept of multi-flash pictures, a much more accurate form of measurement.
So what you are seeing here on the projector screen, we are seeing a car which is moving. Okay, this diagram now illustrates the displacements. After 1 second, the car has moved this distance, which is S1. After the second, it has moved this distance.
The purpose of this section is to develop the concept of representing actual motion with pictures and graphs.
I would say, especially when teaching maths and science, be as practical as you can. So to refer whatever you're talking about to the everyday things that happen in life. So it's much easier for them to understand and to relate if you are quoting examples for things which happens around them. This is how we interpret motion using graphs.
In this example, the class is simply looking at constantly accelerated motion with the use of other types of motion implied.
Purpose behind this video and the lesson that's shown on the video was to show how learners can interact with the real movement and begin to understand how it can be represented so that one can move from the real movement to pictures of it, to measurements of it, to tables of data,